Alright, this is the second diagram where we're learning how to draw valence electron core charge diagrams. Alright, so I'm going to shift my paper over here a little bit. Should have probably done that beforehand, and we're going to use this sheet here to complete some of these diagrams here. So let's start with hydrogen. How many valence electrons does hydrogen have? Well, the only shell that has an electron in it is this one right here, which is close to the nucleus. It has one. So I'm going to go over here and I'm going to color in one spot there to represent the valence electron for hydrogen. Now remember, everything else to the interior of that is core. When I look in here, there's no more electrons, all right? So I don't have to worry about charge. So those zero negative charges, but I also have to consider the number of positive charges from the protons in the nucleus, and there it is, 1p positive. So I got one positive charge. So when I take zero negatives and one positive charge, add that together, I get an overall core charge of 1 positive. All right, let's do lithium just below that. All right, lithium, how many valence electrons? 1. So I color that in, color it at the top. How many core electrons do I have? 1, 2. So that's 2 negatives. What's my protons for lithium? 3p positive. So I write 3 positive. When I add these together, 2 negative plus 3 positive, I get an overall charge of 1 positive. All right, so let's jump to group 2. Beryllium. How many valence electrons does it have? 1, 2. So I'm going to color those in, top, bottom. I'm going to look for now the number of core electrons, 1, 2. 2 negatives. How many protons do I have? 4p positive. So 4 positive there. When I add these two values together, I get an overall charge of 2 positive. Okay, let's do magnesium. All right, how many valence electrons does magnesium have? 1, 2. So I'll color that in. 1, 2. How many core electrons does it have? Well, what's just inside of that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 negatively charged electrons. How many protons does magnesium have? 12p positive. So I write 12 positive there. Add those two together, I get an overall core charge of 2 positive. All right. We did aluminum in the previous video, so let's do boron. Boron has 1, 2, 3 valence electrons. So let's color that top, bottom, left. How many core electrons does it have? Well, what's just inside of this outside valence shell? Well, this shell right here, and I get 1, 2 electrons, so I write 2 negative there. How many protons, positive charges does boron have? 5. So 5 positive. When I add 2 negative and 5 positive together, considering the negative and positive value that they have, I get an overall core charge of 3 positive. Silicon, we did in the previous video, so let's do carbon. Carbon has 1, 2, 3, 4 valence electrons, so we write 4 negative. How many protons does it contain? 6. So 6 positive. When I add those two together, I should be getting a different value. Oh, sorry, I messed up. Even teachers make mistakes. So I want to fill in my valence electrons, 1, 2, 3, 4. All right, that's where this is the 1, 2, 3, 4 that I'm filling in. What I'm supposed to do next, again, is take the core electrons, which are 2, not 4. So let's change that to 2. So 2 negatives and 6 positives will give me a core charge of positive 4. All right, the reason I backtracked there is because I knew carbon doesn't have a core charge of positive 2. It has a core charge of positive 4. All right, so let's shift this over and go to this side here, and let's do a few of these right here. So let's do nitrogen. So nitrogen has 1, 2, 3, 4, 5 valence electrons. So we fill that in, top, bottom, left, right, top. All right, that's the pattern that we used before. How many protons does it contain? 7. So that's 7 positives. How many core electrons does it have? Well, we just filled in or used the valence electrons there. So we have 2 core electrons. So that's 2 negative. When I add those two together, I get an overall core charge of positive 5. Hopefully you're beginning to see some patterns here. Let's move to oxygen. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So we go top, bottom, left, right, top, bottom. So there's our 6 valence electrons. How many core electrons does it have? Well, what's left? Those 2 there. So we got 2 negatives. And we get to look at another protons. So it's 8 p positive. So that's 8 positives. So 2 negative and 8 positive. When we add the negative and positive integers together, we're going to get an overall core charge of positive 6. Can you predict what fluorine is going to be based on the pattern that we're seeing here? Well, hopefully you predicted 7. We're going over on this side, you got 1, 2, 3, 4, 5, 6. Well, maybe that progression here is going to continue. So let's confirm that. So fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So let's fill that in. Top, bottom, left, right, top, bottom, left. How many core electrons are left? Well, these 2 here. So 2 negatives. How many protons does fluorine have? 9. So 9 p positives or 9 positive charges. 2 negative and 9 positive gives an overall core charge of positive 7. Yes. And then we got neon. Let's do that one. Its valence shell is full. 1, 2, 3, 4, 5, 6, 7, 8. That's the case for all noble gases. So let's fill in neon like that. And let's count up its core electrons. Well, what's left? It's these 2 right here. So that's 2 negative. And how many protons does it contain? Well, it has 10. So 10 positives. Add those 2 together, you get a core charge of positive 8. Okay, so hopefully you're going to see some trends here, and you should be able to fill out the remaining ones here: helium, as well as sodium, potassium, and calcium as well. Okay.